All right, physical science students, we're going to be talking about Newton's laws of motion today. We're going to be discussing Newton's second law, described by the algebraic equation force is equal to mass times acceleration. Again, second law is basically the idea that we talked about in Newton's third law. Net force of an object is equal to the product of its mass. So that would mean that, mass times acceleration. So that would mean that if I know the mass of something, I know how fast it's accelerating, I can determine what the net force will be. And obviously with any algebraic equation, if I understand how much force is being applied to something, and I know the mass, I can figure out the acceleration, or if I know the force and the acceleration, I can figure out the mass. So it's a equation that works with itself to find three different variables. Kind of a neat little equation, Newton's second law. Okay. We talked about this just a little bit in our little bit of a lab experiment where we talk about the idea of mass as it increased on the spring scale will increase the amount of downward force that is read on the spring scale. So what we find is that net force and mass are directly linked to each other. So the more mass you have, the more net force that will be required. Now this particular graph is discussing gravity. So you can see up here in the right-hand corner, 9.8, that would be the acceleration. Again, since force and mass are equal to each other, this tells me that if I take the force over here on the y-axis divided by the mass on the x-axis, I would find the slope. And this slope turns out to be the acceleration. So this acceleration in this case is referring to the acceleration due to gravity. So this would be 9.8 newtons per kilogram. The accepted number is about 10 for shorthand. Okay? So the slope of the line was 9.8. On your graph, an acceptable slope is between 0.96 and 1.1, given the equipment that we were working with. So this force per mass is referring to how much pull gravity has on mass, and the slope is also equal to what we know as acceleration. That's the slope, so force and mass would find the acceleration. So again, acceleration is the change in velocity over time. So the speed is the change in distance over time. Acceleration is a vector quantity. So an accelerating object can change its speed. It can also change its direction. Again, this is all review for you guys. Okay? So an accelerating object can change its speed pretty simply, and it can also change its direction. That's acceleration. The acceleration is due to gravity is about 9.8 meters per second squared. So an easy way to say that is about 10 meters per second squared. Right? Now, Newton's second law proves that different masses accelerate to Earth at the same rate. So if we would find it mathematically, we could actually figure out that if I have a certain mass and I know the acceleration due to gravity, I can figure out what force it is. Or I can figure out what force is being pulled on the object. And this has a tendency to have the same acceleration. If I take the force due to gravity divided by the mass, I can figure out the accelerating object's about the same. All right. Now, when the mass is in kilograms and acceleration is in meters per second squared, the unit of force is generally newtons. Okay. So 1 newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second per second. So this kind of gives us, again, the idea of 10 newtons per kilogram is the generally accepted acceleration of objects back to Earth. So the second law, force is equal to mass times acceleration. Again, it's a fairly simple written formula. Force is equal to mass times acceleration. So here's a sample problem. How much force is needed to accelerate a 1,400 kilogram car 2 meters per second per second? Well, given the things that we have, the variables we have within the equation, this tells me that I can take the mass, 1,400 kilograms, times the acceleration, 2 meters per second. And I should be able to solve and figure out the force that's required, which is 2,800 newtons. Here's another little table that we've set up for you. You can go ahead and pause the video and work out some of the blank spaces. You can see we have 2, so you can use a little reasoning based on what we have going on here to figure out what these 2 are. Okay. And here are a few checking your understanding. Again, you can pause the video and see what you get on this. Here are the answers. And again, here are some other places where you see net force being applied within gravity. Of course, friction comes up in net force, electricity and magnetism also apply forces. So these are the review of Newton's 3 laws of motion. First law, of course, is inertia. An object at rest will stay at rest. An object in motion will stay in motion at constant velocity unless it's acted on by an unbalanced force. We talked about that in Newton's 3rd law. Second law goes force equals mass times acceleration. And the 3rd law, for every action, there's an equal and opposite reaction.